Okay, guys, moving on to inverses. So an inverse, remember how we said they're only defined in certain quadrants? Our inverses, we are now going to be given the trig function, and they want us to find the angle. So we're just doing the opposite. So the first one says use a calculator to find the value in radians of the following expression rounded to 2 decimals. You simply type it in the calculator, but make sure you are in radian mode. So if I have my calculator, I'm going to go up here. I'm not in the right mode. Sorry, because I cannot see this right here. So I got to make sure I change it to the right mode. Up degree radians. Sorry. Now it's in radians. So I just type in sine inverse. I have 0.9. Enter. I get 1.119 or 1.12. That's all you have to do for that one. Okay, next one. Find the exact value of the following expression. Sine inverse of -1. Okay, this is asking what angle does the sine of theta equal -1? When I see sine or cosine equaling 0 or 1, I think unit circle. Also, when I see tangent or cotangent equaling 0, I think unit circle, because the tangent inverse of 1 is actually 45 degrees, right? Okay, so what I did is I filled in my unit circle here. So where's the y value, -1? Down here. But do not give the answer of 3 pi over 2. Remember, because for inverses, it goes negative pi over 2 to pi over 2. So the answer is negative pi over 2. Another way to check this, guys, is to put your calculator into degree mode. And if you type in sine inverse and you type in -1, I'm doing it upside down, sorry. Sine inverse of -1 and hit enter, it's going to tell you -90 degrees. If you can then convert it to radians and get negative pi over 2, it's going to help you check your answers. Okay, next one, same thing, tangent inverse of 0. Guys, look, I'm leaving it in degrees. Where does the tangent equal 0? Second, tangent inverse 0, enter. It's at 0 degrees or 0 radians. But also look what I did here. What angle does the tangent equal 0? Well, it's sine over cosine. So my sine is 0, my cosine is 1. 0 over 1 is 0. That's how I figured out what my angle was there. Okay, just a few more. And then we move on to 8.2, the composites. Okay, here it gets a little busier. So here we're having one where the beginning we have the inverse on the outside and the regular trig function on the inside. So what's going to happen is if we have tangent of an angle and then an inverse on the outside, we have to look at this angle. Is this angle in the defined range of the inverse? Negative pi over 7, yes, it is in the defined range for the tangent. So if it is, then we're just taking the tangent and then undoing what we just did. So our answer will be the same, negative pi over 7. When is it different? Right here. That's why I put both of them. So now I have tangent of 4 pi over 5. Is 4 pi over 5 in our defined inverses for tangent? No, because it's quadrant 1 and quadrant 2. So what we're going to do is we are going to draw 4 pi over 5. So here's my lovely XY axis. I'm drawing 4 pi over 5. It's the purple right here. 4 pi over 5 is in quadrant 2. That's not in my defined inverse interval for my tangent. So what I do is I say, well, is my tangent positive or negative in quadrant 2? It's negative in quadrant 2. So I need to move this reference angle, pi over 5, into the negative tangent quadrant, which is quadrant 4. So your answer here becomes negative pi over 5. Okay, last one. Now we have the inverse on the inside and the regular trig function on the outside. if this is tangent and cotangent, you are always going to get back this number because our range from our original tangent functions was all real numbers, right? The only reason this won't happen is if this would be a cosine inverse of 3 and then a cosine on the outside. And if you type that in, you'll realize it's undefined. That's the only one where you would have no solution. Because remember, cosine and sine just goes back and forth between 1 and 0, right? So for tangent, you're going to give me the answer back. For sine and cosine, if it's between -1 and 1, you give me the answer back. But if it would be 3, like it is here, for cosine or sine, you would tell me no solution. Okay, next we're moving on to composites, guys.